afternoon. Welcome to my TV channel. Welcome back. Alright, good afternoon, viewers. This is your YouTube channel where you listen and you learn chemistry. And today I'll be teaching particulate nature of matter, part 2. And in particulate nature of matter, there are some things we'll be learning today. The last video, we talked about the particles of matter, which is atom, ions, and molecules. And we also look at atoms. That atom is the smallest particle of an element that can take part in a chemical reaction. We will look at those particles, which is proton, neutron, and electron, and we'll try to define atomic number and mass number. Atomic number, we say, is the number of protons in the nucleus of an atom of that element, while mass number is the sum total number of protons and neutrons in the nucleus of an atom. And in this video, I'll be explaining how to determine the mass number and the atomic number of an element. The mass number and the atomic number of an element. Now, when you check the atomic number, right from the arrangement of elements are arranged according to their atomic number. Hydrogen happens to have atomic number of 1 and a mass number of 1. Now, the next element is helium, which is 2. The mass number will be 4. Now, how do we determine the mass number, especially for elements between atomic number of 2 to atomic number of 7? Now, from helium, the next one is lithium. Lithium is 3. Now we have times 2. You just multiply the atomic number times 2. That gives you 6. Yeah, although we have isotopes of lithium with atomic number of 3 and a mass number of 7. Now, when you check through to nitrogen is 7. The atomic number of nitrogen is 7. The mass number is 14, which is times 2. Okay, but even when we take right from oxygen down to calcium, which is 20, how do we get the atomic number and the mass number? The atomic number, when the atomic number is even number, you multiply by 2. 8 multiplied by 2 is giving us 16. The mass number of oxygen is 16. Then the next one is what? Fluorine, 9. Fluorine is odd number. When the atomic number is an odd number, you multiply by 2, then you add 1 to that number. 9 times 2 is 18 plus 1, that's what? 19. Now, when you check aluminium is 13. It is odd number. Times 2 is 26 plus 1 is what? 27. Then let's come down to calcium. Calcium is 20. Now 20 times 2 will give us what? 40. Now with this, we have been able to establish how to determine the atomic number and the mass number of elements from 1 down to 20. It's very easy, in as much that you know your first 20 elements, but as a chemistry student, I expect you to learn the first 30 elements from hydrogen to zinc, And this time around, let's look at how to determine the atomic number, mass number, number of proton, neutron, and electron of atoms. Okay, now we are going to be taking sodium as an example. Sodium, when you count sodium, according to the atomic number, that's according to how it has been arranged on the periodic table. Sodium has atomic number of 11. Now let me ask you before I'll write it out, what will be the mass number of sodium? Now the mass number of sodium, how do you get it? Since it is odd number, that's times 2 plus 1, 22, then plus 1, that will be what? 23. So the number of proton, which is P, that's the atomic number, that gives us 11. The number of electron, being a neutron atom, all atoms have the same number of proton and electron, that will be what? 11. Now number of neutron, neutron, if you want to get that, you just say mass number minus the atomic number, because mass number is the number of proton and electron. So atomic number is 23, atomic number is 11, 23 happens to be the mass number of sodium. So 23 minus 11 will give us what? 12. Okay, that is for sodium. And let's take one more atom. Now let's take an atom that is a non-metal, and this time around let's take oxygen. Oxygen has an atomic number of 8. Now let me ask you, what will be the mass number? The mass number is what? Yes, the mass number is 16, which is times 2, being even number. So the number of P, which is proton, is what? 8. The number of electron is what? 8, also being a neutral atom, while the number of neutron happens to be what? 8. That is 16 minus what? Minus 8. Is that taken? So even when you are given any if you are being given any element or atom, because atom is smallest particle of an element, to determine with the proton, neutron, and electron, just determine their atomic number first, then get the mass number. From those two values, you'll be able to get the number of proton, number of electron, and number of neutron. Okay, that takes us to ions. What are ions? Ions are atoms carrying electrical charge or charges. Ions are atoms carrying an electrical charge or what? Or charges. They carry electrical charge or charges. So if an atom is able to lose or gain electron, it becomes an ion. So like sodium having atomic number of 11, when it ionizes by the loss of one electron, then the electron becomes remaining 10 out of 11 electrons. Okay, now let's analyze that. Now Na plus, the atomic number is 11, the mass number is still 23. So what will be the number of proton? The number of proton is still 11. It will never change. So when atom loses electron, it is the electron that is affected. It will be deficit of electron, and the electron will be short depending on the charge on the atom. Now number of electron, that will be what? We have supposed to be 11, but since one electron has been donated, or there is a loss of one electron, because all metals ionizes by electron loss, so we have 10 electron remaining. And mind you, all ions are stable in the sense that they become an ion because to attain a stable configuration, just to look like group 8 elements, to have 8 at the atomic shell. Those metals that are before or after the transition element, they lose electron to look like the transition element before them, and those metals accept electron to look like the to look like the group 8 element before them, the element having 8 at the back. And if they're able to have 8 at the back, that's ascertain their stability. Okay, number of neutron. So it is just like we have it in atom, which is 16 minus 8. We also have it the same thing here, 23 minus 11. That gives us what? 12. Okay, now this time around, let's take a positive or a negative charge ion, which is called anion. Sodium happens to be a cation, so let's take an anion. So taking an anion, let me take chlorine for example. Now chlorine has atomic number of 17, so what will be the mass number? The mass number will be what? 17 times 2 then plus 1, which is what? 35. So number of proton is given us 17. Yes, number of electron will be what? So since one electron has been added to it, so 17 plus 1 gives us what? 18. The number of neutron will be what? That will be 35 minus 17. Now what is 35 minus 17? And that's giving us what? 18. So in the course of this class, I will want you to solve this as an exercise. And if you have any comment, I will want you to drop your comment at the comment section, and don't forget to subscribe and like this video. You can share the video also so that other students and people can also benefit from this video. All right, I want you to calculate the number of proton P, electron E, and neutron for the following particles. And one, we have let's take magnesium, atomic number of 12. 2, let's take fluorine, atomic number of 9. 3, let me add aluminium, 13. Then 4, let's pick a cation. Let's pick potassium plus, which is 19, atomic number of 19. And number 5, let's take oxygen. Oxygen is 2 minus, and the atomic number of oxygen is what? 8. So just follow my examples and try to work this out. All right, and in the next video I'm going to explain other aspects of particulate nature of matter. Don't forget to subscribe to this YouTube channel. Thank you. God bless you.